When dealing with environments in Nuke, it's quite handy to know your ins and outs with LatLongs and full 360 environments and all that. A common problem is, how do I retouch a spherical environment with all the distortion I get at the poles? So that's something we'll be looking at in this tutorial. So let's have a quick look at this random piece of sky over here, and we'll be using this to fill in the gaps in our LatLong at the top up here. Obviously we have huge distortion at the top, so we need to bring those two into the same world somehow, and that's what the Spherical Transform node can do for you. So if you transform the incoming LatLong map to a cubic map, then you get a reasonably undistorted cubic field of view. If you do that, make sure that your output format is set to a square format, otherwise you'll be distorting the image. And once you've got this set up, you can now use the rotational controls at the top to rotate the LatLong as if you were inside of a dome. And if we just, let's say, look up by 90 degrees and reset the Y rotation, we can now concentrate on retouching our top tile that is looking along the positive Y axis. So now we can just slap this guy on top. So let me create a quick alpha mask. And while we're here, we'll pre-mold the whole thing as well, and put that on top of our extracted cubic map. Obviously that needs some adjustments, so let's insert a transform node and tweak that a little, rotate the hotspot over where it should be, and also adjust the Bezier shape to actually cover that black hole. And then we'll just drag some soft edges outwards. I'm not going to worry about the cranes. I mean, this is just the concept I'm trying to get across here. So obviously you'd spend a lot more time making this pretty in production. But let's pretend this is just what we want. Maybe do a bit of grading on top of that. Adjust the white point a little bit and bring up the gamma. Sort of like that. And now we're pretty much ready to transform that back into LatLong space. However, if we did that, then we'd be filtering the image quite heavily. So what I like doing is usually consider this as my template setup and then use a second Spherical Transform node to convert this straight into LatLong space and merge it with my original image. In order for me to do this, I need this to be a true cubic map. And if we look at it at the moment, it's kind of a random format with a random bounding box, so let's fix that first. And you can use a reformat node. I'm just going to use a crop node in this case because I need to make sure it crops to the lower left corner, and with a reformat node I might forget to adjust that properly. So if I just do a 800 by 800 box and reformat it to that, make sure the black outside stays off so we don't affect the Spherical Transform node's output by that. Then now we basically have a valid cubic map. So now in the Spherical Transform node we can say the input type is a cube, well, one cube face, and the output is a LatLong map. And if you output a LatLong map, you should output to a 2:1 image aspect. So I'm going to use the 800 by 400 resolution I've got here. And that's simply because the LatLong displays 360 degrees horizontally and 180 degrees vertically, so it's a 2:1 aspect. And the next thing we need to do is connect this to the right pipe. We are looking up, so this is actually positive Y. So I'm just going to drag the pipe out from the side and right click once to get plus Y. And now if we look at the transform node, we don't really see a whole lot yet. And that's because the primary pipe, which is the first pipe of each multi-input node in Nuke, isn't connected yet. And since we don't really care about that -Z view, I'm just going to hook it up to a black constant. Like so. And you see the moment it's hooked up, we are actually getting pixel information. So now we're ready to merge this on top of our original LatLong. So I'll connect that to the background, this to the foreground, and over the whole thing. And now we're getting some artifacts here, and if you look closely you'll see that we're actually losing the alpha channel along the way in the Spherical Transform node, and that's because the primary input doesn't have an alpha channel here. So we need to make sure that the constant node has an alpha channel, so it allows for that to be piped through. So I'll switch it to the RGBA layer, and that gives us the alpha chip, and the artifacts are gone. So obviously now you can go back and play with this and adjust your grading and your mats and everything. But what if I don't want to retouch on a LatLong and I want to retouch my original 3D scene instead of having to bake it into a spherical map first? So let's have a look at the original tileset, which consists of a bunch of cards and is obviously a bit hard to retouch in a normal conventional 2D kind of way. So what I tend to do is spit out a LatLong map as a template, pretty much go through the whole setup here, but then instead of doing the 2D merge of the spherical map, we can then actually output the spherical transform onto a sphere. And because we'll be inside of the sphere looking out, we need to mirror the texture. So let's do that, like so. And now we've got our sphere and we've got our little cap that we can now 3D merge with our original tile set. So I just connect both to a scene node and look at the top. I can now actually get rid of this tile. So if I just double click that, so now our sphere is taking care of our top part and the rest is taken care of by the original tile set. So if we pan around, we still see a few artifacts, but those are only happening in the OpenGL view. So this is the UV seam that you see and this bright halo here. Both of those things are going to go away when you render. So let's do that for a second to make sure that I'm not talking shit. Hook up a camera, connect to the camera and lock, and then rotate the whole thing to actually look at some of those problem areas. So there's our halo and here's our UV seam. And if you now switch to 2D, you'll see both of those are gone.